now we shall talk about the disinfection, next one, right? So storage, filtration, and then disinfection. Now we shall talk about the disinfection methods, right? Okay, so now let's talk about the disinfection in the large scale purification of the water, right? In the disinfection, mainly we need to talk about three things over here. First one is the chlorination. Obviously, for the chlorination method, we have talked about in detail in the last session itself. Okay, so chlorination, we are using the chlorine gas over here. We are using the chlorine gas, and the size over here which we'll be using, it will be more than 0.5 parts per million ppm, right? After a contact time of 1 hour. After a contact time of 1 hour. Okay, so please remember that for the sake of MCQs, after a contact time of 1 hour, right? Then we are having a method of ozonization. Ozonization, I will tell over here that it is not having a very long period of residual time. So that's why residual time means it will be not filtering the water very efficiently. If you talk about that ozonation alone is enough for the purification method, then it's not a true statement over here, because it might be needing the other filtration methods along with it. So it might be used, but it might be used with the other filtration methods also in a combination manner, but not separately, because separately it will not be able to do the purification over there. It might not be able to give the justice to the purification of the water, right? So ozonization, if I will talk about over here, so in this case, for the good ozonization, we might be using the gas that is more than 0.5 milligram per liter, right? So for the good ozonization, I would say, for the good ozonization, guys, we might be needing the gas over here. Okay, and this gas, what will be the quantity we'll be using? More than 0.5 milligram per liter with contact time of around 20 minutes. Contact time of around 20 minutes. Okay, that will be used over here. And I told you already, next important point over here, that if we want to get the good purification of the water, it can't be used separately. It has to be used with the combination, other combination methods of the filtration, right? So they don't have the residual effects, and due to that residual effects, so they needs to be used along with, or they needs to be used, or they needs to be coupled with other methods of filtration, right? Other methods, fine. And the next one which we shall talk about over here, so we are having chlorination method, we are having the ozonization method for the disinfection of water, and we are having the next one, that is the membrane process method. In the membrane process method, we are using several kind of filtration products, right? Some of them you might have heard about and you might have seen also. So first method which we are using over here, the semi-permeable membrane. Semi-permeable membrane, we are reading about it from our childhood days only, that from the 8th and 9th class only. The semi-permeable membrane is actually used to filter, the water will be passing through it, and it will be passing through the very, very small pores, right? And we will be talking about the sizes of the pores, and accordingly different filtration processes are available to us, right? So basically water will be actually passing through the small pores over here, right? So water will be passing through the small pores, right? So here it will be used for the filtration process. So it will be doing the filtration process, filtering the water by using, or filter by passing water through the pores. Now the size of the pores might differ, and on the basis of the size of the pores, we can say that this filter is better or this filter might not be better and all. So on the broader picture, we can classify that on the basis of high pressure pores and the slow pressure pores, or high pressure pores or the low pressure pores. So we might be having two classes over here, that one could be the high pressure pores, right? High pressure pores, or I can say high pressure processes, or the slow pressure processes, or the low pressure processes. In the high pressure processes, we are talking about two particular filters, right? One is the reverse osmosis, and another one is the nanofiltration. So if we talk about high filtration, high pressure, we shall talk about two methods over here. One could be the RO system, which is the reverse osmosis process. RO system, which is the reverse osmosis, right? It is having a pore size of around, it is having a pore size, it's having a very fine pore size over there. It is having a pore size it will be lesser than 0.002 micron, 0.002 micrometer. If you talk about the next one, that is a nanofiltration. Nanofiltration is also a very good one, but over here the pore size is around, the pore size will be around less than 0.01 micrometer. Okay, so still which one is best, guys? The best over here would be the reverse osmosis, right? The best over here would be the reverse osmosis over here, right? Now we might be having the low pressure processes, low pressure processes. In the low pressure processes, we might be talking about the ultrafiltration and the microfiltration. If we talk about the microfiltration, right, microfiltration and the ultrafiltration, right? So for the microfiltration, the size over there which we are using, pore size. Okay, so the pore size might be asked over here. Pore size for the microfiltration, it is the less than 0.1 micrometer, and if you talk about pore size of ultrafiltration, then it is less than 0.2 micrometer. Okay, please do remember that as well. So till now we have talked about what? About the purification of water and the disinfection. Purification of water can be achieved by the, on the larger scale and the smaller scale. Smaller scale we have already talked about in the initial session, and in the larger scale we have to talk about the storage, we have to talk about the filtration, rapid and slow filter methods, and we have to talk about the at last we have to talk about the membrane processes, where we have to talk about high pressure system, high pressure processes and the low pressure processes. High pressure if we talk about, then we are having a reverse osmosis and the nanofiltration. We have to talk about the pore size also. Reverse osmosis is having a very small pore size, that's why the filtration quality is also better as compared to the other methods. In the low pressure processes, we are having the we are having the ultrafiltration and the microfiltration, and we have talked about the pore size as well, right? So thank you so much for watching this one, and with that we have completed the series of the water, right? Now we shall talk about some of the MCQs also, guys, and then we'll wrap up this session. So if you talk about the MCQs, guys, very simple MCQs. You can practice by your own also, but some of the MCQs I have taken over here. Okay, and after that, after listening to all these 3 sessions, okay, just go for the MCQs and you will be able to solve many of them. So guys, over here we shall talk about first one. They are saying over here that in a chlorination of the water, the main disinfecting agent is due to, I told you that hypochlorite ion, right? Remember, hypochlorous acid and the hypochlorite ions, these are the 2 important ions which were actually made up for the chlorination purpose over there. And which was the best one? I told you hypochlorous acid was more effective, 70 to 80% more effective as compared to the hypochlorite ions, right? So here the answer will be what? Here the answer will be the hypochlorous acid. So here the answer will be the hypochlorous acid. Okay, so no doubt about that. Now next question is, residual chlorine is detected by. So guys, residual chlorine is detected by what? I told you residual chlorine is detected by the, yes, 2 methods, orthotoluidine and the orthotoluidine arsenite, right? So orthotoluidine arsenite was able to give us the results separately, that residual chlorine is that much and combined chlorine is that much, combined residual chlorine that much. So over here the answer would be the orthotoluidine test. Okay, and the modification of that test was one more test over there, that was the orthotoluidine arsenite test, isn't it? OTA test, which I told you in the last session only, orthotoluidine arsenite test. Okay, it was the OTA test. Okay, so please remember that as well. Third one, guys, Horrocks apparatus they are asking us is used for what? Horrocks apparatus, I told you that in the detail also. I have shown you the image as well. If you guys remember, I told you 6 white cups and the 1 black cup. We will be using the starch iodide as a reagent over there. Okay, how to use that, all of these things we have discussed in detail. So over here we used to use the we used to calculate the bleaching powder dose, and I told you whatever cup is getting bluish color first, it will be considered as that color is actually having the residual chlorine. So over there the formula was N into 2 grams of the bleaching powder, which will be used for 455 liter of water, for 455 liter of water, right? If you guys remember over there. So over here they are just simply asking us for what purpose we are using. We are using it for the calculating bleaching powder dose for the water disinfection, right? Okay, and I told you that disinfection of the wells is done by what? Bleaching powder in itself. Fourth question, guys, again easy one, indicator agents to determine the fecal pollution of the drinking water. So I told you it has to be calculated, it might be calculated by the coliform index. right? And coliform index, I told you the main one which we shall use over here, that is the E. coli, right? It is the E. coli. It is the most sensitive tool for the determination of the fecal matter in the drinking water or the disinfection for the disinfection purposes. So this is the E. coli over here. That should be the answer over here. So E. coli would be the answer, right? And I told you it can be calculated by the help of McCartney chart as well. Okay. Then in India, at least how many meters away the sanitary well should be located from the likely source of contamination? So guys, in India, if you talk about, at least they are talking about what should be the distance. So over here, at least 15 meters should be there. At least 15 meters should be there, right? Okay. So that was about what? That was about the discussion of these important MCQs as far as these this water section is concerned, right? So I hope you enjoyed the session. Please go through it once again and try to solve some more MCQs, right? Thank you.